This is a video on points of intersection of polar graphs. The question states, find the points of intersection of r equals 1 plus the sine of theta and r equals 3 sine of theta. So I start out by setting these equations equal to each other to find the intersection. And I get 3 sine of theta equals 1 plus sine of theta. So now just subtract sine of theta from both sides, divide by 2, and I get sine of theta equals a half. So if you remember your trig, that occurs either when theta equals pi over 6 or theta equals 5 pi over 6. So now I want to find my r, and I can just plug my theta into either of these. I'm going to choose r equals 3 sine of theta. That's the simpler one. Sine of theta for either of these is a half. So I get 3 times a half, or just that r equals 3 halves. So now let's find the x and y coordinates. I have x equals r cosine theta and y equals r sine theta. So I plug in cosine of pi over 6 is root 3 over 2 times r is 3 root 3 over 4. And sine of theta is a half for either of these, actually. So I get a half times 3 halves is 3/4. And then cosine of 5 pi over 6 is the same as cosine of pi over 6, but negative. So I end up getting negative 3 root 3 over 4, comma 3/4, because remember, sine is still a half. Now, it looks like we're done because we've gotten our points. On the other hand, if we graph this red curve that kind of twists around, and this circle, and we see that there's actually 3 points of intersection. We missed one. So setting them equal to each other doesn't always give us the whole story. We can see from the graph that the origin is also a point of intersection. So for the first curve, notice that when theta is equal to pi, r equals 0. And for the second curve, when theta equals 0, r equals 0. So it's different thetas, but when r equals 0, every theta gives you the same point, that is 0, 0. So our final answer is we get the 3 points of intersection, 3 root 3 over 4, comma 3/4, negative 3 root 3 over 4, comma 3/4, and 0, 0. And I'm done with the problem.